Quick question. What happens when a misconfigured skill tries to read your SSH keys, or a bad exec call starts writing to your home directory? Right now, nothing stops it. Your agent runs bare on your machine with full access to everything. I'm Adhiraj, and welcome to day 12 of the OpenClaw bootcamp. Today, we're going to fix all that with Docker. It's the same agent, same config, but now it can't accidentally or maliciously touch anything that you didn't actually mount in. And this is the foundation for tomorrow's VPS deployment. Let's containerize. On day 11, you wired up the deeper integrations. So Google Workspace for email and calendar, web search backend configuration, browser automation with SSR protection, webhooks and cron triggers for event-driven and scheduled automation, and custom integration chains. Your agent is now plugged into the services that you actually use. Today, we're covering three things. So first, why Docker matters specifically for OpenClaw agents. So isolation, reproducibility, sandboxing, and the security boundary it provides. Second, the practical setup. So the Docker Compose configuration, sandbox modes, volume mounts, and networking. And third, production patterns. So how to run your containerized agent with systemd, log rotation, health checks, backups, and a zero downtime update strategy. Let me make the case for Docker specifically in the context of running an AI agent because it's different from why you'd containerize a typical web app. First, isolation. Your agent has shell access, file system access, and the ability to make HTTP requests. On a bare host, a misconfigured agent or a malicious skill could touch anything, like your SSH keys, your home directory, your other services. In a container, the blast radius is contained. The agent can only access what you explicitly mount. Second, reproducibility. So pre-built OpenClaw images are available on the GitHub container registry. So you pull an image, you get the same exact environment everywhere. Third, sandboxing is built in directly to OpenClaw's architecture. You can set agents.defaults.sandbox.mode to non-main, and that's going to tell the runtime to spin up per session Docker containers for non-main sessions automatically. Your sub-agents get their own isolated container. You combine this with gVisor for kernel isolation, and you get defense in depth without any custom infrastructure. And fourth, easy rollback. If an update breaks something, you revert to the previous image tag. Your workspace and config live in the volumes, so the agent's state is completely independent of the container image. Getting started is straightforward. You want to install Docker. You can use Docker Desktop on Mac OS or Windows, Docker Engine on Linux, and then you want to create a Docker compose.yaml file. The compose file needs three things: the OpenClaw image, which you pull from the official registry, port 18789 exposed, which is the gateway port that channels and clients connect to, and volume mounts for your config and workspace. The critical volume is /OpenClaw. This is where your agent's configuration, credentials, model registry, and session state live. Mount it to the container so everything persists across restarts. Your workspace directory gets its own mount as well. That's where the sole agents and memory markdown files all live. Once that file is ready, use Docker compose up/d. That's going to start everything in the background. Your existing config carries over seamlessly through the volume mount. If you've been running OpenClaw locally for 11 days, all that's set up so your personality, your memory, and your operating rules right there in the container. Sandbox modes are where Docker and OpenClaw's runtime intersect, and understanding the three modes plus the scope and access settings is essential. The mode setting controls who gets sandboxed. Off means no sandboxing, so everything runs on the host. Non-main means non-main sessions, so sub-agents, background tasks run in the per session Docker containers. The main agent runs on the host. All means every session, including the main agent, runs inside a Docker container. The scope setting controls container sharing. Session gives each session its own isolated container, so that's maximum isolation. Agent means all sessions for a given agent share one container. Shared means that all agents share a single container. Workspace access controls what the sandbox container can see. The default is none, so the sandbox has no access to the workspace at all, just its own file system. RO gives it read-only access, mounted at agent. RW gives it read-write access, mounted at /workspace. And for maximum containment, you can enable gVisor. This is an application kernel that intercepts system calls and adds another isolation layer between the container and the host kernel. This is the paranoid but correct approach for production agents that handle sensitive data. Now let's walk through production-grade compose configuration because the quick start version I showed earlier is minimal. Volumes break down into three categories. Workspace volumes for your agent files, so your sole agent skills, everything in the workspace directory. Credential volumes for the API keys, auth tokens, and provider configurations, and session volumes for conversation history and session state, so your agent doesn't lose context when you restart the container. Environment variables are how you pass API keys into the container. Never bake credentials into the image. You want to use environment_file.environment to load from a file that stays out of the version control, or use inline environment blocks for non-sensitive config. For networking, you want to bind to 127.0.0.1 by default with loopback only. That's loopback only. If you need remote access, use tail scale. Do not expose the ports publicly. Health check should hit the gateway port to verify that the agent is responsive, and the restart policies should be set to unless stopped for production. One feature I need you to know is the sandbox.docker.setup command. This lets you run custom setup scripts when the sandbox containers start. You can install additional packages, configure tools, or set up environment-specific dependencies that your agent's skills might need. Docker security for AI agents has a few gotchas that don't apply to typical containerized apps, and the biggest one catches people off guard. Docker bypasses host UFW rules entirely. If you're running on a Linux server and relying on UFW for your firewall, Docker containers can reach the network unfiltered. The fix is to add explicit rules to the Docker user IP tables chain. This is the only chain Docker respects for user-defined filtering. If you skip this step, your containerized agent has unrestricted network access, regardless of what your UFW config says. For container hardening, run as a non-root user inside the container, set the config file permissions to 600 and state directory permissions to 700. You want to require gateway auth for all connections, never run an unauthenticated gateway. Network restrictions go beyond the firewall, so you want to bind to 127.0.0.1 to prevent external access, unless you've explicitly set up a reverse proxy or tailscale. Drop all unnecessary Linux capabilities, so never run in privileged mode, and restrict the outbound traffic to only the API endpoints your agent actually needs, like your LLM provider, any duration endpoints, and nothing else. Good news here is that when you stack Docker isolation with Sandbox mode, tool policies from agent's markdown file, and gateway auth, you get 4 independent security layers. Any one of them can fail without compromising the whole system. That's defense in depth. Running Docker in production means handling the things that don't matter in development. So auto start, logging, backups, monitoring, and updates. For auto start, you want to create a systemd service file that runs Docker compose up on boot and Docker compose down on stop. Set restart equals to always with restart sec or seconds up 10 seconds so the container recovers automatically from crashes. This is a standard pattern for any long-running Docker service on Linux. Log rotation is important because agent logs grow very fast. Every conversation, every tool call, every sub-agent spawn generates output. Configure Docker's logging driver with max size and max file limits so logs don't eat up your disk. Backups are simple because your workspace is just markdown files. Use Git to version control your sole agents and memory files and your daily notes. The key insight here that you need to take away from this is that everything important is in the volumes, not in the container. So your backup strategy is just back up the volumes. For monitoring, you want to use gateway.channel health check minutes to configure how often the gateway checks channel connectivity. Pair this with Docker's native health check to get container level monitoring. If the health check fails, Docker can restart the container automatically. Updates are the cleanest part. Pull the new image with Docker compose pull and then restart with Docker compose up-d. Your workspace and config live in the volumes, so updates are non-destructive. The old container stops, the new one starts with the same mounted data. Pre-built images are available with latest main and version-specific tags, so staying current is just a pull and restart away. 4 things before day 13. First, you want to install Docker, get Docker Desktop on Mac OS or Windows, or Docker Engine on Linux. Second, you want to create a Docker Compose YAML file. This is the file you're going to carry forward to day 13 when we deploy to a VPS. Third, run your agent in a container. So run Docker Compose up-d and verify that your agent is reachable from your configured channels. Fourth, test Sandbox mode. Also spawn a sub-agent and verify that it gets its own Docker container. Check that the sub-agent can't access the host file system, and this is going to validate that sandboxing is working end-to-end. Your agent now runs in an isolated, reproducible, production-ready container, but it's still on your local machine. When your laptop sleeps, your agent sleeps. Day 13 is VPS deploy, and so taking this exact Docker setup and running it on a cloud server that never turns off. Your agent is going to be running 24/7, handling messages while you sleep. If you want hands-on help with Docker deployments or anything else in the series, consult with me at aliwarchungle.com. And if you want to build and sell AI automations alongside other builders, join the free AI automation sprint. Links in the bio. Subscribe so you don't miss day 13, and I'll see you tomorrow.